We're going to utilize the time that we have today to make sure we have a solid understanding of what a discrete random variable is, the notations, the type of problems that we'll be doing. Now, a random variable is random variables are variables in which there is a numerical value for the outcome of a random, I want to say phenomenon, but a random occurrence. Each numerical value outcome, which we define as x, has a known or calculated probability, p of x. So, we will also be talking about, and when I talk about discrete random variables, which is what we are covering, these are outcomes that are specifically known for all possible outcomes. We'll also, towards the end, talk about continuous random variables and how that applies. In other words, you can have we in this case we know the outcomes, what the outcomes are. So, in terms of notation, we define a random variable problem / situation with a capital letter. Typically capital X, but also Y, Z, W, B. These ones might be more for context. So if we're talking about somebody's weight, we might use a W. But we can also, typically in a problem though, we'll just use X and Y. Typically in the problems that we're going to be doing today, we're just going to use the random variable X. It's our, just like how you do problems, you define the input as X and so forth. I know you haven't taken, discrete mathematics, but X is the set of all outcomes, capital X, and therefore it's a capital. And if we do lowercase x, sub I are all the numerical outcomes possible for X, for capital X. So, you know, we don't typically use the subscript notation too much within this course, but the idea here is that we say that X is equal to all the possibilities. So we say like X1, and this is capital X, X2, X3, X4, dot, 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 X, Xn. And each of those are the possible outcome or values that you can do. All right. So for example, X could be the set -1, 2, 8, and 16, where these are the possible numerical outcome values. So those are the outcomes. For example, you're playing a game. Let's say you're gambling with money, right? And your outcomes are that you could lose $1, you can win $2, you can win $8, you can win $16. We'll talk a lot about some of these gamblings and stuff on that. It has a big large parts here. And this could be a game, and it sounds like a great game. Wow, I might lose $1, but I might win $16. Sounds amazing. Well, it turns out that you would lose the dollar, 80% of the time. And maybe, 2% of the time you would win the whole $16. And so there's a very small chance that you win the bigger ones and a very big chance you lose and even, relatively small chances that you win the 2 or the 8 type of things, type of outcomes. So we define those as the outcomes. Now, if I ask, hey, what is the probability that X equals -1, we might say something like 0.8. Now, typically you won't see it this way. You'll see as the probability of -1 equals 0.8. You might see something that's written like this. And what that means is that we get the outcome of X, that the outcome is X. But we would notate it as P of -1 is there. We might have something like the probability that X is 2, and probability that X, and I'm emphasizing the capital letters. The reality is that when you do the work, you might still use lowercase letters in here, and it's not going to be a biggie. Just for notation of the lecture part, I want to do it. 8, and the probability that X is equal to 16. You might get something like 0.15, 0.04. And what does that mean that the last probability must be? Can anybody chime in? What does that last one have to be? Somebody? What is the probability that X is 16? What is the probability that we get 16 as our outcome? This should be a basic answer, basic question right here. I've given you enough information where you know what the last answer has to be. Yeah, 0.01. I want to note here that if given all other probability outcomes, then can always calculate the final probability since the sum of probabilities equals 1. In other words, we write this as this little squiggly e of p of x must equal 1. So we know that the sum of all the probabilities, and that's the notation, the little squiggly e, is 1. So the notation is that this means the sum and typically we say from I equals 1, in this case to I equals n, to our final one, of px sub I is 1. This is the more technical notation, and all this means here in this case is that, so that's the mathematical probability random variable notation, and what this really means is p of x sub 1 plus the probability of the second outcome plus dot 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 plus the probability of the final outcome. If I add them all together, they must add up to 1. So the summation technically. So that's something to note that can be helpful, all right, in terms of those pieces of information. So we have different outcomes. These probabilities might be given to you, they might be stated, or you might have to calculate them. So in some of your problems, you're going to have to calculate what the probabilities are. Random variable tables. Basically, in all of these problems, we need to, a random variable table is a table that states all possible random variable outcomes and corresponding probabilities. And you're going to, in some of your homework problems, you're going to be given this. So, for example, i.e. from above, the problem might look like, it would look, typically you go left to right, but it could be up and down. We have x, which are all of the outcomes, and then we have p of x, which is their probabilities. And in this case, as I said, we had -1, 2, 8, and 6. These were the different outcomes. And you can also flip it. Sometimes you might see the probability written on top and the x on the bottom. There is no wrong way to, if you flip it up and down, left and do it, left and right type of thing. Usually you want to go from the smallest outcome to the largest outcome. It's typically what's done. And then we had 0.8, 0.15, 0.04, and a 0.01. And that was a 16 right there. Typically, given, but may have to use probability calculations to fill in probabilities. Last unit. So first and foremost, I want you to know what these tables mean. So X means that we have some situation, some variable. Now, like I said, we might have X and then we might have Y, we might have Z. And that when the purpose of those ones is that they might have different outcomes or they might have different probabilities. So for example, one person's chances of winning of the game might not be the same for everybody. Maybe a child doesn't have as good of a chance as an adult. And so the probabilities might change. The outcomes could change or the probabilities could change. And all we would do there is we would change the letter of the variable. We call this, sorry, I used the word table there. That is incorrect. I wanted to use the word model. All right, we call this the probability model. The probability, probability model is often what I refer to this as. And it's a table. It states all the outcomes, the numerical outcomes, as well as the probabilities for each of those outcomes. Questions? Calculating probabilities for probability models. Now, basically, this is a probability problem with numerical values attached to the outcomes. Basically, have to calculate all possible outcomes and probabilities. Remember, you don't need to calculate all, since last probability sums to 1. There are certain problems that become a little bit tricky in terms of calculating, and you might remember, you know that they need to add to 1. If you know how to calculate some of them, you want to move forward in doing those. And if you don't, and you have a mistake, then sometimes it's easier to do, ones versus the other. So let's do an example. Let's say we're playing a game. All right. Here's an example. You flip a coin. We're going to make this quite simple. You're going to flip a coin 2 times. You win $0 if you get no heads, $2 if 1 heads, and $5 if both heads. Okay. We want to create a probability model. That's the question right there. Now, you will need sometimes space to make your calculations. All right. So, basically, when we're creating this probability model, okay, we know we need to figure out what the outcomes are and what are their probabilities. So, what are my random variable outcomes? The random variable outcomes. What are the results that could happen? The numerical results that could happen.
0, 2, and 5.
0, 2, and 5. Now it's important. These are numerical outcomes. Now, each of these numerical outcomes is associated with some type of outcome. And so sometimes in these ones, when we have to calculate them, we might want to note which these are. So this happens when we get 0 heads. This happens when we get 1 head. And this happens when we get 2 heads. Okay? Now, we know the probability of a heads is what? For flipping a coin, what's the probability of getting a head? And sometimes you might see a fair coin. In a situation, if you flip a coin once, what's the probability you get a heads?
1/2.
Yeah, so 0.5. All right. So what's the probability that I get a heads and a heads? How do I make that calculation? How do I calculate the probability that I get heads and a heads? If I know the probability of getting a heads is 0.5, what's the probability I get a heads and then a heads?
1/4.
Well, yeah, but how do you calculate that? How am I calculating that? I need that for the notes. How do I?
1/2 times 1/2.
Yeah, 0.5 times 0.5, which gives me 0.25. Now, are there any other ways of getting heads, 2 heads? If I flip the coin twice, are there any other ways of getting 2 heads? Are there any other outcomes that I can get? Any other ways I can get 2 heads? Yes or no? Yes or no? Any other way I can get 2 heads? No, the answer is no. There's no other way you can get 2 heads. The only way you can get 2 heads when you flip a coin twice is if you get heads on the first one and heads on the last one. So 0.25. So the probability I get, so this is the probability of 2 heads. The probability of no heads would be the probability of not a heads and not a heads. Well, it's a fair coin, so this would be also 0.5 times 0.5, which is also 0.25. What's the probability that I get 1 heads? Well, how can I get 1 heads? Can you tell me how I can get 1 heads? Now, I'm not looking for the answer yet, but how do I get 1 heads?
If you flip one, it's a tail, and then the next flip is a head.
So it equals the probability of a tail, and a plus, and then a heads. Is that the only way?
No, you can get heads the first time and tails the second.
So it's actually, there's two different ways. Remember, if we do the tree diagram, so this is why drawing a tree diagram could be helpful. Heads, tails, heads, tails, heads, tails. So there's two ways you can get one heads, a heads, a tails, or a tails and a head. And so we actually have to do two probabilities, which is 0.25 times 0.5, sorry about that, times 0.5 plus 0.5 times 0.5, which gives me 0.25 plus 0.25, which is 0.5. Now, here's why I bring that up. That is a much difficult, when there's more than one way, and in our next chapter, we're going to find out how to do this problem in a slightly different way for this last piece right here. But calculating no heads is rather easy. Calculating two heads is rather easy. So this is two heads, this is a one heads, and 0 heads. Calculating no heads or two heads was very easy, and since those two add up to 0.5, the last one has to be 0.5. Now, I showed it through the calculation, but I know that these have to add up to 1. So since I got 0.25 and 0.25, the other one had to be 0.5 without even having to go forward with the calculation. And now you have your probability model. So these type of questions up here are very similar to the type of questions that you got yesterday, or you got in our previous unit. I will ask you, for example, you might deal with a situation where, you know, so for example, and I don't want to go in like, if you flip over a card and it's an ace, then you get the money, and if it's not an ace, then you do it again. And if you get an ace, you get a different amount of money, but if it's not, you do it again. And if you flip over an ace, you win a different set amount of money, and you keep going, and then that's it. You don't get to play the game anymore. The game ends. So we can talk about, you know, the chance that you flip the card over, or it, you know, you have to list out all the possible outcomes within the problem. I kind of want to hold those off for tomorrow. So I think I'm going to end there. And I know I do have like 14 minutes left, but I don't want to push it too much. We're going to talk about the next level of this. I want you to be able to digest this type of information. And we're going to move forward with tomorrow. I'm going to delete the current assignment that's on there. Well, actually, I'm going to move that assignment to tomorrow. And I'll add in a materials piece for today's notes, and also noting that there was no homework assigned today. Take care of your other classwork, other coursework, and also this classwork as your term ends. We are going to be doing, like I said, sometimes these are given to you. All right. Sometimes it's just straight up given to you, and you're asked to do certain things and calculations. We'll talk about those calculations tomorrow. First one being expected value, and sometimes you have to create it. Sometimes they're very nice and they actually label to you what the different outcomes are, and sometimes, you know, you have to just calculate the probabilities and so forth. So that's what I have for you. I'm gonna move today's till tomorrow. So the problem, don't do these problems because I haven't instructed you on what is expected value. We'll spend our time tomorrow on that. That homework will be due Friday, and then of course Friday, we'll have a new assignment after that. That's what I have for you. Take care, everybody. Close out your term strong, and I'll see you tomorrow.